All right, so thanks for attending. This is BCA1995, Design, Deploy, and Optimize SQL Server on VMware ESXi. So just a brief introduction about me. I've been with VMware for about 4 years now, and it's really changed. I think my first year we had 3,500 employees, and now we're up over 10,000. My first VMworld, we had about 5,000 people here. Now I heard the last count was over 25. So it's amazing how virtualization has expanded and grown and moved into the business critical app space, which is what we're going to talk about today. So what I do at VMware, I work on the solutions engineering team. We focus on virtualizing tier 1 applications like Microsoft, Oracle, SAP, Java, those sorts of things. And prior to that, I spent many years as a professional services consultant working on Microsoft products like the above mentioned, and also some identity and access management projects. So the disclaimer, standard disclaimer, we won't read through that, the legalese. Let's go straight to the agenda. So I am going to frame the presentation with just a few overview slides. I believe there are only 4 of them, so give me some patience and go through those 4 slides just to kind of set up the value proposition of why you would want to virtualize SQL Server on VMware. Then we'll dive technical. And you can really think of SQL Server workloads in 2 categories, or you're really going to address virtualizing SQL Server workloads along 2 vectors. Number 1, your tier 1 production workloads. And there you're concerned about performance, you're concerned about application SLAs, and so we'll cover things like how to allocate resources properly, how to monitor and troubleshoot a tier 1 SQL Server, and some in-guest tuning that you can do in order to improve performance of those tier 1 workloads. But the next section after that is database and licensing consolidation. So this is more concerned with not necessarily excluding tier 1 databases, but looking at consolidation from a broad perspective across the enterprise. What are the best consolidation strategies? How can I save money on licensing? And then finally, we'll finish up with availability and recovery. So how do you protect your SQL Server workloads? Do you just use VMware HA and vMotion? Can you cluster? Can you mirror? And we'll show you how to use those in combination with each other to get the best out of your virtualized SQL environment. Finally, we'll finish up with more information. There's some slides. There's a slide in there with some links to online documentation. Most people don't know that we have a business critical applications website with best practices guides and availability guides and things like that are really deep dive technical based on lab work that we've done both internally at VMware and with partners. And I finished the presentation up with a long list of reference architectures of our partners that have done testing for SQL Server 2008 on vSphere. So moving into the overview, again, only 4 slides, so bear with me. What we found in surveying our customers is that CIOs and IT operations obviously want to virtualize more. And there's some really good reasons for that. Infrastructure efficiency, lower cost, simplified management, built-in availability, and greater agility, the ability to respond to changing workloads. But some application owners need convincing. They want to know if the application will perform well. Will Microsoft support it? And what's in it for me? Why should I virtualize this application when it runs great today? And you'll get some other things in there too, like today I have a dedicated piece of hardware that I can work on, that I control. Why would I want to turn that control over to a VMware infrastructure admin or a storage admin? So, quick poll of the room. I noticed in the first time I gave this session that there were a whole lot of DBAs in the room. So I want to know how many DBAs are in the room today. Okay, good. Now, who's a VMware infrastructure administrator? The vast majority, okay. All right. Any developers? Hey, all right. So, this is tailored more toward the infrastructure admin, but there's a lot of content in here for DBAs as well. So I'll definitely try to call that out as we go through. A little marketing slide here, won't take too much time on it, but VMware did a lot of surveys with our customers to determine where they are in virtualization adoption. And we found out that most companies fall into one of three stages. They're either in stage one, where they're beginning virtualization, virtualizing low-end workloads like IIS or file servers or non-critical servers. Then they'll reach a point where there's no more of those workloads to virtualize. What do I do next? That's where business critical applications come in, and that's stage two of the customer adoption journey. The ultimate goal is once you've got everything virtualized, it's sort of an ideal to shoot for. You've got your private cloud or your IT as a service where everything's automated, everything's governed, and you have easier change management and overall operation efficiency. Who else is doing this? So if you look at our poll in January 2010, let's look specifically at SQL Server. 43% of VMware's customer base had virtualized SQL Server in production as of January 2010. And you can see the other numbers, some good numbers for Exchange, Oracle, SharePoint, and SAP. We redid the poll in April of 2011, and we're starting to see some further adoption, especially on the SAP side. 28% now of our customers virtualize SAP. But we're up to almost 50% of the SQL Server workloads out there are being virtualized. What we're finding is that customers tend to virtualize the low-end SQL servers first, and then they move on to the more mission-critical workloads. So some of the benefits, server consolidation, save money, fully utilize all of the hardware, consolidate SQL Server with minimal impact to your applications. We'll talk about that in section 3. And consolidate SQL Server licenses. We found out that many SQL Server instances are underutilized. And because they're underutilized, you end up paying more in licensing than you need to. Operational advantages like responding to changing workloads. What happens if there's a change to the application or you merge with another company and a bunch of new users come in and the original design requirements that you specified are no longer applicable. Enhancing testing and troubleshooting. That's always been a great use case for VMware. And isolating database virtual machines from security threats, either through creative use of virtual switching or a product like vShield. Finally, higher availability with less complexity. I did a group discussion on Monday, and this was the number one reason that people wanted to virtualize Tier 1 applications. They believe that vSphere offers a higher level of availability. We allow you to reduce planned downtime with things like vMotion. We can reduce unplanned downtime out of the box without any clustering or any add-on software with VMware HA. And we also have a product called Site Recovery Manager that can protect the entire site from failure regardless of the application. So that's it for the intro. Let's do a little bit of a deep dive on Tier 1 workloads, architecting for performance. So performance is very important to SQL Server because it's important to the applications that rely on SQL Server. And in many cases, you're held to an SLA by the organization. And a slowdown on the SQL Server level will slow down the app and will make you look bad to the business. So we're going to show you how to get the most out of SQL Server by allocating resources properly, by monitoring and troubleshooting to be able to identify bottlenecks, and some SQL Server in-guest tuning parameters. So in the past, organizations were reluctant to virtualize Tier 1 workloads just because we couldn't handle it. ESXi only supported one CPU. We only supported 2 gig of RAM and less than 5,000 IOPS. If we fast forward to today, now we can scale to 32 virtual CPUs at 1 terabyte of RAM per VM. And we have a white paper published where we were able to produce 1 million IOPS to a single ESX host. To put that in perspective, Visa's global credit card transaction processing system produces about 60,000 IOPS. So this is an older test. Large-scale tests on SQL Server take a whole lot of resources, especially if you're trying to generate 32 CPUs worth of work. So you know vSphere 5 just came out. We are in the works with a lot of our partners to do some vSphere 5 testing. I believe there's one in the works where we're doing SAP on SQL Server, where the SQL Server scales to 24 cores. But this will give you an idea of how we scale compared to physical servers, even on vSphere 4. So if you look at the left, that's our scale-up test. We started out with a virtual machine and a physical server with one CPU, moved up to 2 CPUs, then up to 4, then up to 8. So once we got up to 8 virtual CPUs, you can kind of see what we would call the virtual machine overheads. At 1 and 2 virtual CPUs, we ran at 92% of native performance. At 4 CPUs, we ran at 88% of native performance, and 8 CPUs, we ran at 86%. Now, those numbers don't sound great until you look at the workload. We were running 3,000 transactions per second in the virtual machine with 8 CPUs. Average response time was 255 milliseconds. We ran at 25,000 IOPS, and we actually had less disk latency than the physical server itself by 1 millisecond. Now, if we go back and look at the scale-out test, most customers will tend to stack multiple SQL servers on the same ESX host. And in a lot of cases, that means that involves overcommitment of resources like CPU and memory. So we wanted to measure the effect of CPU overcommitment when running multiple SQL workloads on the same ESX host. So the ESX host on the right had 8 physical cores. Each VM had 2 virtual CPUs. So by the time we reached 4 VMs, we were actually utilizing 1-for-1 virtual processor to physical processors. But then we overcommitted by a factor of 2 to 1 by adding 8 virtual machines, each with 2 virtual CPUs. So even once overcommitted, when we moved from 4 to 6 VMs, we saw a 1.5x improvement in performance, and moving from 6 to 8, we saw a 1.4x improvement in performance, even though we were overcommitting processors by a factor of 2 to 1. When we started seeing performance degradation is when the ESX host itself was pegged at 100% utilization. Now, going back and looking at the transactions, 2,760 transactions per second, aggregate across the box, at an IOP rating of 23,000. It's important to understand the type of workload that you're virtualizing. If you're doing Exchange mailbox servers, you know what workload you're looking at. If you're sending and receiving 100 messages a day, you know pretty much what you're going to generate in terms of CPU, memory, and disk I/O. But SQL Server is a little different because it depends completely on the application that's running against it. So here are 3 types of workloads 3 general types of workloads that we see for SQL Server. Online transaction processing. That tends to generate a large amount of very small queries, tends to create sustained CPU utilization during working hours, but tend to not operate very heavily at night. They're also sensitive to peak contention. So if the SQL Server slows down, the application slows down, it affects the SLA. Batch workloads tend to operate at night and tend to be systematic operations. They tend to be write-intensive, tend to run off-peak hours with low CPU utilization during the day, and are not so sensitive to peak contention. They're more, when you design these, you want to design for sustained activity. Decision support systems are used periodically. So a small amount of very large queries. They tend to be CPU, memory, and disk I/O intensive when they're running, but they tend to run infrequently, like the end of the month, end of the quarter, or end of the year, like accounting systems. So let's look at the OLTP and batch workloads and compare utilization across 24 hours to show you the difference between these 2 workloads. Both of these workloads average 15%. So at a high level, you would say they were pretty much the same. But when you look at hour by hour, you see that they're very different in the type of workload they generate. So if you look at the OLTP workload, we saw the majority of the activity during business hours, and again, the batch workload, the majority of the activity was at night. So the reason we like to show this comparison is when you're doing consolidation, you want to take this into account. These would be 2 great workloads to co-locate on the same ESX host because they're using processor at different times of the day. And this might be a great candidate for overcommitment of processor because you're not using the processors at exactly the same time. You need to factor in this kind of intelligence when you're trying to achieve high levels of consolidation with SQL Server. So the performance lifecycle, just a few steps when you first start designing the SQL Server onto when it's been deployed into production. Number one, most important thing is monitor your existing workload over time so that you can establish a baseline. Monitoring an existing workload is better than any best practice. Once you monitor that workload, you know exactly how that workload performs on physical servers. You can design your virtual machines accordingly. If you don't have an existing workload to monitor, you can estimate application activity using vendor guidelines. So if you're running an application like SAP, they've got some very good guidelines for how to design the database to support it. Or work with your ISV vendor and pull in some professional services to help out with those sorts of things. The great thing about virtualization is you don't have to be right the first time. You can always add or remove processor and memory to a VM. You can always add and remove storage. You can always scale out. Virtualization makes changing easy, so you don't have to bet the farm on your initial design. Once you've determined what you need, then you allocate CPU and memory resources based on those requirements. It's better to estimate low than to estimate high because we can always hot add CPU and memory to a running VM. Design storage to accommodate both capacity and throughput. I don't know how many times when I was consulting, we would implement a database for a particular application, and the application owner would say, well, we need 2 gigabytes of storage. Well, what kind of storage do you need? How fast does it need to be? How many spindles? A lot of times when people design these things, they don't think in terms of throughput. They just think in terms of capacity. That's very important to consider both. Then you deploy to your ESX hosts. Once the VMs are deployed, the operating system and SQL are installed, you want to optimize the guest OS and SQL Server configuration to get the most out of it. And then finally, monitor and optimize performance. We'll talk about each one of these in the next few slides. So resource allocation. We used to say, never, never, never overcommit. Well, now we're a little more mature. We have people with experience with vSphere. So what we say is, overcommitment is something that can be done if you do it intelligently and you monitor it. So for virtual CPUs, allocate the minimum requirement and adjust as needed. You can always use hot add to a running SQL Server virtual machine. DBAs out there, I hope you're aware of that. We can add processor and memory to a running SQL Server without interrupting that SQL Server. You want to avoid physical CPU overcommitment for Tier 1 production workloads unless, let's say you have the batch and the OLTP workload. Let's say overcommitment makes sense in your case. If you are going to overcommit, monitor these counters up here to make sure that you keep that under control. You also want to keep NUMA node sizing in mind with sizing virtual machines. A NUMA node is basically a socket. And so if you want to eke out every last bit of performance out of a VM, sizing the VM within one NUMA node can help enhance performance. For virtual memory, make sure that you right-size memory allocations to get the most efficient use of the host memory. Use the latest version of vSphere to take advantage of memory compression. Again, you also want to avoid, that's a typo, avoid memory overcommitment for Tier 1 production workloads. If you are overcommitting for any reason, there's some counters there that can help you keep that under control. Now, storage, just a couple of bullets here, but we'll talk about this more. Understand I/O requirements for each application so that you can avoid performance degradation due to under-provisioned storage. You also want to use redundant paths to your storage array, dual HBAs or teamed NICs connected to separate switching infrastructures to get the best fault tolerance. We've extended in vSphere 5, we've extended NUMA awareness to the guest operating system. It's not something we had before. SQL Server 2008 is NUMA aware, so it'll try to grab memory on the socket where the thread's running instead of hopping across sockets to get memory from another NUMA node. So we can extend that functionality to the guest so the SQL Server can look through the ESX server, see the NUMA architecture, and optimize itself accordingly. It is enabled through the multi-core UI in vSphere 5. It's on by default for new VMs that are created with 8 or more virtual CPUs. If you have existing VMs, they're not affected through the upgrade. You'll have to manually set that. For smaller VMs, you can enable NUMA by setting the configuration parameter numa.vcpu.min equals 4. If you have CPU hot add turned on, virtual NUMA is turned off by default. So once you've turned on this setting, SQL Server automatically detects the NUMA architecture and then optimizes its processes in order to take advantage of that architecture. Some general storage best practices. Use shared storage. If you're a small customer and you don't have a SAN, we have a new virtual storage appliance that you can use in lieu of a SAN. But shared storage allows us to use features like vMotion, HA, and DRS. Create any VMFS file systems from within Virtual Center to ensure partition alignment. Now, this is extremely important to SQL Server. If you're using VMFS, format VMDK files as eager zeroed thick, especially for database and log files. This is an old screenshot with vSphere 4. You could turn that on by checking the support clustering features such as fault tolerance. I didn't have time to put the vSphere 5 screenshot in here, but the vSphere 5 allows you to pick thick or thin as one of your provisioning options. You want to choose thick in those cases. You'll see on a later slide, we've seen up to a 50% performance hit by not formatting your VMDKs eager zeroed thick. Let's talk after. Being filmed. You also want to use multiple vSCSI adapters to evenly distribute the target devices inside of the virtual machine guest. So you don't want the software itself to be a bottleneck. Every virtual SCSI adapter is a thread. And if you have multiple threads, that means you can do more work. So a good best practice for SQL Server, put the OS on vSCSI 0, put the database on vSCSI 1, and the logs on vSCSI 2. You can even spread them out further and put half your databases on one vSCSI controller and half on the other. If you're using a Windows version prior to 2008, then be sure that you do a partition alignment inside the guest. You can suffer some pretty heavy performance hits if you don't. Windows Server 2008 does this for you automatically, so you don't have to worry about that. We get asked a lot when to use VMFS and RDM, and the answer is becoming more and more VMFS. There are a couple of examples where you have to use RDM, but for the most part, we generally recommend VMFS. You can get into trouble with VMFS, though, because unlike an RDM, which enforces a one-to-one mapping between the LUN and the VM, VMFS can contain many VMs. You can put multiple VMDK files on that volume. The problem is that the more VMDK files you put on there, the more you can experience contention for that same set of storage. So you have to be very careful. And there's a formula here on the third line. Manage performance. The combined IOPS of all the VMs on a LUN should be less than the IOP rating of the LUN itself. If you have a LUN with 5 disks and it can do 1,000 IOPS, then you don't want to put more VMs on, 1,500 or 2,000 IOPS worth of VMs on that LUN. Now, RDM can save you from that because it's not impacted by the IOPS of other VMs. The downside to RDM is that you're more likely to hit the LUN limit of 255 LUNs that can be assigned to an ESX host. And that's effectively 255 LUNs per cluster because every host in the cluster is going to be connected to the same storage. When do you have to use RDM? If you're using Microsoft or SQL Failover Clustering. SQL Failover Clustering uses a shared disk component and issues SCSI reservations. So we require RDM disks for that. If your storage vendor has SAN management tools like backups, snapshots, replication, a lot of times they'll require RDMs for the databases and logs. Otherwise, use VMFS as a best practice. When you're laying out your database, follow the same guidelines as physical. Separate LUNs for data and logs. For Tier 1 production workloads, maintain a one-to-one mapping between the VM and the LUN, whether you're using VMFS or RDM. And your design effort should now be a joint effort between the DBA, the VMware admin, and the storage admins. So resource allocation summary. Use and monitor CPU and memory overcommitment carefully. If you want to just be absolutely sure, avoid overcommitment at all for Tier 1 production workloads. Storage I/O is the most crucial element of performance for SQL Server. If you correctly size your storage or your disk spindles to deliver the required IOPS to the application, and you correctly configure the storage array, I/O performance on VMware should not be an issue. We have many, many studies that show there's no difference between the I/O generated by a virtual machine versus a physical server if the underlying disk is the same. For mission-critical SQL databases, design is physical, one-to-one VM to LUN mapping. If you're looking at smaller workloads like departmental databases, it is possible to consolidate LUNs with multiple VMs. It depends on the IOPS that you're looking for, and that is also a potential storage I/O control use case to make sure that the correct VM is getting the right IOPS. So a couple slides on SQL Server guest tuning. There are a few things you can do inside the guest to make it run a little more, a little faster, a little better performance. Use large pages in the guest, and you can do that by starting the SQL Server service with the trace flag -T834. You can enable lock pages in memory to the SQL Server service account. And then one recommendation is to set maximum server memory and min server memory based on the following formula, which I will not go through. Those dashes are minuses, by the way. So, some in-guest storage best practices. Microsoft fully supports Microsoft workloads running on VMware. Matter of fact, they even announced support for vMotioning non-shared disk clusters in Exchange. So they're fully behind us from a support perspective. One of the reasons is we always tell customers to follow Microsoft best practices. We didn't write SQL Server. Follow their guidelines. Plan for performance instead of, or in addition to capacity. So use a large number of small drives instead of a small number of large drives. Make sure that you ensure sector alignment. We talked about the Windows 2003 and previous sector alignment problem. Pre-allocate your data files. You don't want them to auto-grow during your peak activity. Use multiple data files for data and tempDB. For tempDB, the guideline from Microsoft is to start with one tempDB file per CPU core or virtual CPU. If you have a tiered storage environment, the database file placement priority from fastest to slowest drive should be transaction logs go on the fastest drives, followed by tempDB data, followed by the data itself. Place those files on separate LUNs to get the best performance. Use tools like Iometer to test to make sure that you're getting the IOPS that you expect. And then inside the SQL Server, perform routine maintenance with index rebuilds and DBC checkDB routines. So some monitoring and troubleshooting. I've been wanting to put this in the deck for about a year now. Hopefully this will be of help to some of you. First, I'm going to cover the in-guest monitoring tools. So DBAs, this is for you. If you don't have access to the vCenter, maybe you don't have the credentials or they haven't given you access, you can still monitor performance from within the guest using Perfmon. So VMware Tools now includes a Perfmon DLL that gives visibility into not only the guest CPU memory and disk usage, but also the resource usage on the host itself. You can use SQL Server Profiler to monitor performance at a Transact SQL level. And then SQL Server Dynamic Management Views can be used to monitor the overall health of the SQL Server guest. There is a link down there at the bottom if you want some more information about that. So if you're a DBA and you're limited to in-guest monitoring, this is a way for you to identify bottlenecks for your VI admin. You go to your VMware admin and say, hey, I noticed that I have high disk queue links in Perfmon. What can I do about that? That's when the vSphere admin is going to go into one of two host-level monitoring tools, the vSphere Client or ESX Top. The vSphere Client, everyone's used it. It's a GUI interface. It allows you to monitor one or more ESX hosts for performance and configuration data. It's a really nice tool because it's visual. and it requires a low level of privilege to use. Now, ESX Top is much more granular and much more technical. It's designed to monitor one host at a time. It's a command line utility. If you've ever called VMware support with a performance problem, they're probably going to have you launch ESX Top in batch mode to send them those results. ESX Top is a pretty advanced tool, so definitely read up on it before you start messing around with it. Some key metrics to monitor for ESX. I won't go through all of them. We have metrics for CPU, memory, disk, and network. And here are a few of the more common ones. But what I want to drill down on, since storage is so important, are the commands in red. So we have guest average latency, kernel average latency, and device average latency. Picture's worth 1,000 words, so I put this into a picture to help you understand where each of these counters apply. The G average tracks latency of I/O in the guest VM. It's from the guest VM's perspective. Your investigation threshold on that is about 15 to 20 milliseconds. K average is the latency of the I/O passing through the vSphere kernel. That investigation threshold is 1 millisecond, and it's actually measured in microseconds inside of ESX Top. So if you made it to 1 millisecond, you have a problem with the kernel and you need to call support. Device average latency tracks latency at the device driver and includes round trip time between the HBA and the storage. It's about a 15 to 20 millisecond investigation threshold. You might see some spikes on that, but just make sure that overall your average is going to be below that 15 to 20 milliseconds. And if you see any aborts at all in ESX Top, it's probably a bad thing, and you need to investigate the storage. So database and licensing consolidation. So we're going to kind of zoom out a little bit. We talked about designing for Tier 1 workloads, but how do you get the most out of consolidating SQL Server? You know, a lot of people don't realize that SQL Server licenses are tied to the physical host. They're not tied to the VM. We'll talk about that later in the slide deck. But because the licenses are tied to a physical host, and because most SQL servers are underutilized, there are some cases where you can save a whole lot of money in licensing. So let's go through some consolidation strategies. First of all, most SQL workloads are not extremely resource intensive. When we did a poll of our capacity planner database, we noticed, and that's across 700,000 servers, not VMs, physical servers in customer production environments, we found that the average SQL database runs 2 CPUs at 6% utilization. I talked to 50 people in the last 2 days that said their SQL servers were under 30% utilized. 95% of the servers polled were under 30% utilization. Memory's the same way, about 3.1 gigabytes on the average at about 60% utilization. And the IOP number really blows me away. The average database runs at 20 IOPS. 95% of servers polled were under 100 IOPS. That's not to say that you don't have massive SQL servers out there. That's not what I'm saying at all. What I'm saying is most of them are small and are great candidates for consolidation. When you consider your SQL Server consolidation project, I'm not going to read this slide to you. You just need to consider the big picture. You need to consider business requirements, security requirements, management and operation requirements, in addition to all the technical requirements that we've already talked about. So if you're running this project and you're looking out across all the SQL servers in your environment, what you want to do is sort of classify and prioritize your potential migration targets. You're going to want to get the low-hanging fruit, of course, but what's the business value or the cost impact of the migration? Do you have a vendor agreement or a support contract that's getting ready to expire? Do you have a hardware renewal that if you move off of that hardware platform, you could end up saving money on lease costs? What's the resource allocation or utilization? What's the risk of the migration? Is it easy to transition from an operational perspective? And is it easy to transition from a technical perspective? You want to map out all your application dependencies. You don't want to have some surprise when you move the SQL Server over. Oh, this application over here was using it, and now that connection's broken, and the application itself is broken. And then what's the migration impact? Will the migration actually cause an outage, and what outage is acceptable for the application? Anyone in here done a traditional database consolidation, moving from many physicals to one big physical? Anyone? Okay. I've done a few of these myself. You know, this was the way to do it back in the day. You could either install a multi-instance or a shared instance environment. The only difference there is multi-instance means I have multiple copies of SQL Server running, versus shared instance, I have one copy of the service but multiple databases. But they suffer from some of the same problems. There's no isolation from a configuration, a security, or a fault perspective. In fact, one of these databases or instances can run away with all the resources on the box unless you use some kind of utility like Windows Resource Manager or SQL Resource Governor. And there's no load balancing across physical nodes. But the pain point in my mind is in application remediation. This healthcare application over here runs on SQL Server 2005 Service Pack 1. My data warehouse standard is SQL 2008 R2. How do I get that application into the new database structure? What if the ISV doesn't support it? You know, what if I have to make an exception for this particular application or that particular application? So you find that remediation is a continual, painful, effort-consuming process that's riddled with exceptions, as you're trying to maintain the environment over time. So if you look at a better way of doing things would be leave the SQL servers as is. If you're running SQL 2005 on physical, migrate it to 2005 on virtual. We don't really care from a VMware perspective because each VM has its own OS, database, and security isolation. You can leave it as is. You don't have to change the name of the SQL server, the IP address, anything about it, which means no changes to the application. Guarantee resources to SQL servers that need them through reservations, priorities, and maximum. And then right out of the box with no clustering, you can use things like vMotion and DRS to load balance across physical nodes. We feel like that this gives you the best of both worlds in terms of consolidation. Now that's not to say that you can't scale up. We can scale up to 32 cores. So take all of your SQL Server 2008 R2 virtual machines and you could scale them up into one big VM if you wanted to. It gives you fewer VMs to manage, but it also introduces single points of failure because if you lose the VM, you lose all the consolidated databases on there. If you look at the scale out approach, it tends to be better in a virtual environment. Single database per VM, better instance and workload isolation, easier change management, DRS and vMotion are faster with smaller VMs. But it could introduce a little extra management overhead for your DBAs. So most organizations will fall somewhere in the middle. They'll do a combination of a few scale-up servers and a few scale-out servers to achieve their business goals. Now this is the slide I think I like the best because SQL licensing is a little pet of mine. I really enjoy diving into SQL licensing because there are a lot of different scenarios that can really save you a lot of money. So if we consider that the average SQL server in this scenario is 20% utilized, and I'm running 8 of them, each with 2 processors, I'm going to have to license 16 processors. And let's say I'm using Enterprise Edition. So if I add up the cost of the 8 servers, the 16 Enterprise Edition licenses, and software assurance, I'm looking at almost $600,000. But if I'm only 20% utilized, I don't need that many licenses. Remember, licenses are tied to physical servers, not VMs. So I could take those 8 physical servers and turn them into 8 VMs running on 2 ESX hosts. Now I'm using 100% of my processor, and I'm only licensing 4 processors for a total cost of $158,000. This doesn't work when you have SQL servers running at 70, 80, 90% utilization. It works for the smaller ones, though, and you can really save a lot of money doing it. So SQL Server licensing facts. Always refer to official Microsoft documentation. A license is a legal contract between you and the ISV. Follow their recommendations as the final say in what you do in your environment. But some helpful suggestions. Licenses apply to physical servers, not VMs. You can apply multiple licenses to a server. there are two licensing models, server cal and per processor. In general, if your organization already owns client access licenses, server-based licensing can be cheaper in the long run. With per processor licensing, you don't have to worry about buying those cals, but there is a built-in cal in the processor license, and you'll see that reflected in the price list. It's a lot more expensive. So you're essentially paying for that built-in cal over and over and over again. In some cases, it might be better to go with a client access license for every user than it would be to constantly pay for per processor licenses. Your mileage may vary. There are some scenarios where it's better to go one way, others where it's better to go the other. When VMs move, licenses don't necessarily move with them. So with Standard Edition, licenses can only proactively move once every 90 days in a non-failover situation. Now, VMware HA failovers don't count as a move. We're talking about vMotion or DRS. So if you want to use vMotion or DRS with Standard Edition SQL servers, you may need to purchase additional licenses to accommodate vMotion extras. Now with Enterprise and Data Center Edition, that restriction is no longer valid. You have unlimited license mobility rights. If I move the VM from this host to this host, the license can move with the VM or group of VMs. Consolidation rules for Enterprise Edition, 4 VMs per license. So you can have multiple licenses per server. So if you were doing server-based licensing and you wanted to run 16 VMs on there, you could buy 4 enterprise licenses to accomplish that. If you bought SQL Server 2008 R1 before there was a data center edition, you could run unlimited VMs per license. And if you bought software assurance at the time, you can still run unlimited VMs per enterprise license until the next version of SQL Server comes out. That's a grandfather clause for those customers that bought R1 with software assurance. Or you can buy Data Center Edition, which will give you unlimited virtual machines per license. So a few minutes on availability and recovery options. And I got a lot of questions about this at the booth. You know, how do I secure SQL Server? So obviously you want to consider the business level approach. What are you trying to protect? Don't just cluster to be clustering. Or do you really have an SLA? Do you have an RTO and RPO requirement? And how will you test and verify the solution? Let's look at a couple of local site options, and there are 3. We can start at the basic level and use VMware features out of the box like vMotion to reduce unplanned downtime. To reduce planned downtime. DRS will intelligently monitor workloads over time and will automatically vMotion things around your ESX host cluster in order to create a dynamically balanced SQL deployment. And then VMware HA is a hardware failure recovery mechanism. If you lose the host or if the guest blue screens, HA will reboot to another host. We've also added this new API into HA that will allow service level monitoring inside the VM. Consider this a middle ground between VMware HA and Microsoft clustering. So the middle ground is that Application HA, which is provided today by Symantec, will monitor the internal service, like the SQL Server service itself. When it monitors that service and it realizes that the service is down, it'll try to restart the service 2 or 3 times so that it had to avoid a complete reboot. If that doesn't work, it'll default to normal behavior and it'll reboot onto another host in the cluster. Really good solution. We have a white paper out on our Business Critical Apps website, and we have a blog entry about it as well if you're interested. So real quick, how this works, if I have a standalone SQL Server with just HA, I lose the server on the right, HA reboots to the server on the left. It takes anywhere between 30 seconds and 2 minutes. If you can be out for 30 seconds to 2 minutes, this could be enough for you. And it's a really good low-cost alternative to clustering. It provides protection against hardware failures only or OS blue screens, but doesn't give you application awareness. Now, how many people have used SQL database mirroring? A couple of you, okay. We think database mirroring is a great alternative to failover clustering because it offers some of the same advantages. Database replication over IP, no shared storage requirement, which means no SCSI reservations. You can use it for patching, so fail over to the passive node, patch the primary, fail back. The downside is, down and upside of this, is that there are 2 copies of the data, so it's more expensive. But the good side of that is it protects you from data corruption, unlike failover clustering. Automatic failover for supported applications, applications that are mirror aware or have a primary and secondary SQL Server connection string built into the app, automatically support SQL mirroring. If you have legacy applications, you may have to use a DNS alias in order to achieve that. This is really fast. It fails over in 2 to 3 seconds. So if we lose one of the mirror nodes, 2 to 3 seconds later, those databases will fail over to the remaining mirror node, and it's very seamless. It works just like clustering. So if we combine that with VMware HA, we can increase availability. We can use database mirroring to fail over in 2 to 3 seconds. Protection from hardware, software failures, and database corruption. You can use any storage, Fiber Channel, iSCSI, or NFS. RTO is 2 to 3 seconds. Now, when you add in VMware HA, you get an additional benefit. If these were physical servers and I lose one of the mirror nodes, how long do I have to wait until that server's fixed? It could be an hour, it could be 4 hours, it could be a day. During that period of time, that application is unprotected. With VMware HA, 30 seconds to 2 minutes later, you're back up and running. Your mirror reestablishes itself, replication continues, now you're still protected, reduces the amount of time that you were in an unprotected state. The other consideration that my SQL architect brought to me was if you go all day with one of the mirror nodes being down and then try to plug it back in, it could take a very long time for that mirror to resynchronize. Whereas if you're only down for 2 minutes, synchronization can happen pretty quickly. Now let's contrast that with failover clustering. Failover clustering gives you HA using a shared disk architecture. Only one copy of the data though, so it's good for cost, but you have to rely on storage technology to provide data redundancy. But you don't have to be cluster aware. It protects any application or user that's connected to it. But the downside is it suffers from very severe restrictions in storage and VMware configuration. Because SCSI reservations are issued, we can't do things like vMotion. So when we fail over here, the SCSI reservation goes to the passive node, but it's using the same data. We have recently expanded support for Microsoft clustering. So now we fully support the combination of HA and Microsoft clustering, whether it's shared disk or non-shared disk. A shared disk cluster is just like the one we just saw, SQL failover clustering with a quorum disk. A non-shared disk cluster would be something like Exchange CCR or Exchange DAG, where it's really more of a replication model instead of a failover clustering model, even though they still use the Microsoft clustering service. So for non-shared disk clusters, supported on vSphere just like physical, you can use vMotion, HA, DRS. Every VMware feature is available to a non-shared disk cluster. With shared disk configurations, it's supported on vSphere with a few additional considerations for storage protocol and disk configurations, which we'll talk about on the next slide. Now, don't get confused. We say we can use VMFS for shared disk, but that's only if both cluster nodes are on the same physical ESX host. If they go across hosts, they have to be RDMs. So HA with failover clustering, which is supported. HA supported, vMotion DRS or not. But if you were to combine these two, you get some of the same advantages you saw in the mirroring scenario. You can support 2-node clusters. You can cluster physical to virtual or any combination of the two. You can use Fiber Channel or in-guest iSCSI only. NFS doesn't work. Host-based iSCSI doesn't work. FCOE doesn't work or isn't supported today. Supports only RDMs for the cluster databases and logs and the quorum disks. But if you combine HA with failover clustering, you get best of both worlds. You still can't vMotion, but HA will reboot the failed cluster node to another host to shorten the amount of time the database is in an unprotected state. If you want more information about the clustering support, you can look at this link down here, and that'll take you to the KB article. Something we tested out in the lab and expect to see a white paper on this. We hear a lot of customers say we cluster because of patching. That's the only reason we cluster, is just so we can patch while we're online. Our engineer came up with a way to patch a standalone SQL Server with minimum downtime without clustering. It works for VMFS and RDM. Now, it's not instant failover, but you're only down for just a couple of minutes. What you do is you create a standby VM, you patch that VM, and then basically you stop all the client connections on the primary VM, detach the SQL databases, remove the virtual disks, and swing them over to your patched standby VM. Once that's done, you can attach the disks, attach the databases, enable client connections, and now you're up and running with a patched SQL Server. If you want to go back and patch the old primary, that's fine. That old primary can then be your new standby. Works pretty well in the lab. Actually, on our blog site, I think we have a Camtasia video where you can see how this worked. But look for a white paper in the next few quarters that will show how to do this. So remote site options. Just a real quick blurb. You guys know what Site Recovery Manager is. I want to show you a scenario where you can get the best of local availability and combine that with Site Recovery Manager. So database mirroring can be used in your production site to provide local availability. If you have a site outage, well first, either storage replication or ESX host replication can keep your DR facility in sync. Once you lose the site, the admin starts the workflow, reboots all the VMs based on their priorities, and the great thing about this solution is you still have a SQL mirror in your DR site. You're protected at a local site level, whether you're in production or in DR. There's a white paper out from EMC that shows this model with failover clustering in SRM, which might be of some use to you to download. So I'll go over this slide if I get just a few hands. Who knows about vSphere replication? A couple. Brief explanation. You no longer need two SANs and storage replication between them in order to use SRM. You can now replicate from local disk to local disk. You can replicate from EMC to NetApp. You can replicate from EMC to local disk using native vSphere replication built into the SRM product. So it enables replication between heterogeneous data stores and is managed as a property of the virtual machine. It also introduces efficient replication that minimizes the impact to the performance of the VM that's being replicated. Quick blurb in there. Great use case for branch office environments. Anybody have branch offices? Okay, this is how you back them up. You could get an ESX host out there with no shared storage, or even using our virtual storage appliance, replicate back up to the home office, and you have basically disaster recovery for that branch office. So 2 more slides on backup and recovery, and it looks like we're almost done. You have 2 choices to back up SQL Server. You can do the same way you did on physical. You can use an in-guest backup method where an agent's installed inside the SQL Server VM, and you back up normally. Data's sent over the IP network, but as you know, backups affect CPU utilization, and usually these kinds of backups will need to be done after hours or during some kind of maintenance window. Now, if you look at array-based backups, this is a newer model that you might want to consider, because the backup vendor software will coordinate with hardware VSS to create a supported backup image of those SQL Server databases. Then it spins those off as a separate set of disks. Then those snapshotted databases can later be streamed to tape as flat files with no I/O impact to the actual SQL Server. Snapshots take a couple of minutes, and then everything is backed up off of the copy instead of the actual SQL Server database. This is a really good solution if you can implement it, if it makes sense in your environment. So in summary, always follow business requirements for availability and recovery. Don't try to make things more available than they need to be. For hardware level protection, HA offers a low-cost, simpler alternative to Microsoft clustering. Database mirrors are the best of both worlds when combined with HA to allow faster recovery of database servers. Site Recovery Manager lets you protect your entire data center. Failover clustering is supported on VMware virtual machines with some caveats on storage protocol, RDMs, and no vMotion DRS. And then, of course, you have a choice between agent-based and array-based backups to protect virtual SQL servers. So for more information, 2 great websites. Business Critical Apps website that offers best practices, reference architectures, case studies on Microsoft apps, Oracle, and SAP. And we have a Business Critical Applications blog where we've even been known to slug it out with Microsoft on occasion. So pretty interesting stuff there. And then if you have interest in any of these partner reference architectures, please go download those from our partner websites. So thank you very much for your attention, and I hope you have a great conference.